Alright, what's up everybody? This is your second video for sequences as functions. Alright, we're going to talk about geometric sequences as functions. Alright, first thing is we're going to take a look at our sequence 5, 15, 45, 135, and I want to point out two pieces of information that we'll need for our functions. The first is the first term, which is 5. The next is the pattern, which is multiplied by 3. Okay? So we've heard about explicit and recursive already in the first video, so not going to explain that, but do want to explain what a explicit formula looks like for a geometric sequence. And it has the subscript a sub n equals a sub 1, which stands for our first term, multiplying r to the n minus 1 power. Okay? So let's point out. Remember, n stands for an unknown term, number, okay? A sub 1 stands for the first term, and r stands for our pattern, which in geometric sequences is called the common ratio or the growth factor, okay? So let's write our explicit function real quick. So I said we only need two pieces of information, right? Our first term and our pattern. So I write a sub n equals our first term, which is 5. And then in parentheses, I write our common ratio or pattern, which was multiplying by 3. I just write 3. And then I write n minus 1, okay? So we can use this to find any term in our sequence, okay? So for example, if I want to find the third term, okay, I write a sub 3, which stands for the third term, equals 5 parentheses 3. They're multiplying each other. And then I have an n here, right? So I write 3 for n, subtract 1, okay? And if I put exactly what I underlined in a calculator, you're going to get a sub 3 equals 45. Okay? And let's take a look back at our sequence. What's the third term? 1, 2, 3. The third term is 45. Okay? So n, remember, represents the term that you want to find. All right, now we're going to jump to recursive. Okay? So recursive, remember, is the function you use only if you have the term before the term you're trying to find. So for example, if you want to find the 35th term, you're going to need to know a sub 34, okay? If you want to find the 100th term, you're going to have to know the 99th term, okay? So, but what these functions look like is you write it a sub 1, which equals the first term, and then you write a sub n equals your term before the term you need to find, which is a sub n minus 1, multiplying your r, which we already know is your common ratio or growth factor, okay? So for our sequence that we have, it would look like this. A sub 1 is your first term, which was 5. A sub n, we're going to write a sub n minus 1 multiplying 3, which was our growth factor, okay? So let's try to use this to find a term. If we want to find the third term again, okay, we would write it like this. A sub 1 equals 5, and a sub 3, because we want to find the third term, I'm substituting 3 in for our n, which we saw here, equals a sub 3 minus 1 multiplying 3, okay? And wait, again, we have this little a sub 3 minus 1, so we need to simplify this. 3 subtract 1 is 2. So what term do we need to know to use our recursive formula? We need to know the second term, because the second term is the term before the third term, okay? And we look up back at our sequence. What's the second term? 15. So I substitute 15 for a sub 2. And what is 15 multiplying 3? That is going to give me 45. And is 45 our third term back in our sequence? Yeah. Okay. All right, so there you have it. Explicit and recursive functions for geometric sequences. Good luck.